Good morning and welcome to the practical for week 22 for geog1400. My name's Lex Comber. I'm going to try and, this is the first time I've done a kind of video practical, so we'll see how it goes. What you should have done was registered for an account with our studio, and you should have also have, let me just find my, you should have also gone to the VLE for the module. Scroll down in the learning resources to week 22 and you will see that there are some files there, and you will need to download these to work with them and to use in the practical. There are three files you should download. The first is the actual practical document itself. Okay, so there it is, and I'm just going to move that to my downloads. So you need to save these things somewhere where you know where they are. So I'm going to put them in downloads. And the other things you need to get are the practical code. And I think if I click on this, it will save automatically to the downloads. Yeah. And you also need the data. Now this is a bit weird. If you click on it, it will just take you through to an image of the data. So if we go back to the VLE. If you click on it and say download file as in some shape or form, so often this is what happens on a VLE. You get a stupid name. Let's call this one df cleaned data frame .csv, and the .csv is really important because it is a comma separated variable format. If you give it you can change the naming at the front, but the .csv must be at the end. Okay, so if I go to my downloads folder, or the folder where I've saved them, I can see I've got the practical. Oh, it's given it an interesting name. I might change that. Just do that. Thank you very much. And you should be able to open this up, and there it is. Now I'm going to. You will need, for the practical, you're going to need to have the document somewhere. I've actually got another screen with the document on. You may want to print it off. You may want to have it on a tablet, because when we get to work with our studio, I think you'll find that it kind of fills the screen. So my suggestion is that you have somewhere where you're looking at the document, the practical document, and somewhere where, and then on another screen you're actually working through the practical. So I'm just going to get rid of these. Okay, so I'll minimise these. That was my Minerva. So I've downloaded the files, and I've come to our Studio Cloud. Okay. And you need to create an account here. I've already got an account, and so what you do is you log in, and it will pick up my details because I use this quite frequently. And it takes you to a little interface. Now you can see there's some projects here. I've got rid of nearly all of them. I've actually went through the practical a couple of days ago on here, and this was the practical session I set up. But you need to create a new project. Okay, so we create a new project, and what you'll see is our studio will fire up eventually. We're going to give this a name at some point when it opens. My dog is barking to go out the door, but she can wait. Okay. So I'm going to call this week 22. Okay, and we can see then we've got a kind of common R interface. We've got three windows, and from the practical, I'm starting to look on page 2 of the practical, where it's section 2, where it says preparation. Okay, and what you should see is what I'm seeing on my screen is pretty much exactly the same as what's in figure 1 of the practical. I might just make this bigger now. So what I've got is sort of these three panes. I've got the console, I've got something with my environment at the moment, I've got no data in there, and I've got things with files, plots, packages, these things, but really we should stay on file. Okay, so we can, this is we can enter things into the terminal if we wanted to, and we'll do that in a minute. Okay. Now the first thing we need to do is remember we downloaded the data and we downloaded the R script, and the first thing you need to do is to upload those into your workspace. For the moment we'll just upload the script, so I'm going to click on the upload button and then I choose a file. I navigate to where I saved the R scripts, and I'm going to choose that, and if I click OK, it automatically pops up here. Now if I click on this, a fourth pane opens up, and you can see there, if you look through the practical document, I'm now at the kind of bottom of page 2 and at the top of page 3 there's, I've got the first bit of code, the first code snippet. Okay, so what we can do, there are a number of ways. I could type this in, y equals c 4.3 7.1, etc, 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 but I'm not going to do that. Okay, typing will lead to mistakes, it's repetitive and it's boring. Instead, I can either highlight the code and click on run, okay, or I can put the cursor just on the line somewhere and click on run, or I can highlight it and click and press for a Mac it's Command and Enter, and for a PC it's Control and R, okay, or Control and Enter. Okay, so now we can, so I'll run this. Let's just run that piece of code. There she blows. So it's run the first bit of code, and we can see that Y has popped up here. Okay, so what we've done here is we've assigned, we've got a little vector of values, 4.3, 7.1, 6.3, etc. in Y. Okay, so if we now enter Y in the console, we can see those numbers repeated. Okay, so we've created a variable which is here. We can see it in the environment pane, and the variable has a vector of values. So it's not, it has a number of values, and we can undertake operations on those as individuals. So if we run this, this multiplies all of the values in Y by 2. Okay, we can then add all the values up. Oh, great, they add up to 28.2, and we can find out the mean. Okay, so we can undertake operations on the values, and one of the things you should notice there that we've just used two functions. We've used a function called mean, okay, and you notice that what functions do is return a value. Okay, so they take an input of some kind, or they do something to it, and they return a value. So the thing that the function operates on is contained within these rounded brackets. Okay, so if you see a kind of word in R and it's got a round bracket after it, then you know that it's a function. And if it's an inbuilt R function, we can actually examine the help for that by just typing in mean, and what we should get is the sort of description of the function in the help. And usually, there we go, usually there's some examples, and you can run these and kind of go, right, okay, this should tell, I can run these in my, again by highlighting and hitting Control R or Command Enter on a Mac. Okay, and so I've now created something called X, and I can do the mean of X. Okay, so there it's given me some examples. So, but the key point is that functions have round brackets. They usually take a set of values and they return some value as well. Okay, functions should return something. Now going back to the script. Okay, I'm now going to overwrite. I'm now going to just highlight the importance of code. Here, there's a function called the importance of comments. There's a function called rnorm, and it generates a set of random but normally distributed numbers, values. Okay, so this will return 100 values and assign them to x. So I'm now going to overwrite, and you should see the change in x happen here. Unless you've done the help with with the mean x, you won't have x. It will be new. So I can actually, what I can do is remove x. Let's do it that way. There we go. Okay, so I can remove x, but I don't have to remove x. I could recreate x again, and I could just overwrite it. So I'm going to overwrite x now. So now there's a new x, and did you notice that the x changed in here? Now, I'm not really too bothered about x. It's just we've just given some values to a named variable, and we've called them x and y here. There's a couple of things. I could call this bananas. Okay, if I could spell bananas, or Bernard, or my variable. Okay, so it's just x doesn't really mean anything here. It's just a name being given to the variable. The key point was that here the key point of this, we're not going to use x, but what I wanted you to see was that actually it's very important to include comments in your script. So as you work through this, if you come across things that you don't understand, or that you've found out, then you should include a comment about them. Okay, so one of the things I might do here is say, well, okay, functions have round brackets. Our functions have round brackets. Okay, if I can spell and type. Okay, so the basic. What I've tried to show you here is that there is this basic assignment, okay, of values to variables, and the variables are y and x in this case. Now, moving down through to the bottom of page 3, obviously we've assigned values to x and y, but you know, I suppose the most basic use of R is as a calculator. We can enter numbers either manually, 2 plus 2, and R will give me the answer. Equally, I can say what is the square root of 10, and again it will give me the answer. However, I'm not very keen on just entering code into the console here. My view is you should always have your code in a script, okay, which is why I've given you this practical script. I want you to use the code in the script, but I want you to try and understand what's going on, not to remember it, okay? Coding is really not about remembering code. It's just about understanding, because if you can understand what you've done and you can write comments about what's going on into your scripts, then you can always search for, where was it where I did that thing, okay? But R is a calculator, and we can again get the same answers just by highlighting these things and running them, okay? And we can do some fairly fancy calculations, okay? So this one calculates interest on $1,000 or £1,000 or €1,000, compound interest at 7.5% for 5 years. So this is, you know, there we go. There's the interest on £1,000 over 5 years. Now, there's a lot going on here, and we can, you know, we could unpick that, but I'm not going to. There are also some inbuilt values. Okay, I'm now moving through the practical to the top of page 3. Okay, so we can use R as a calculator. It has some inbuilt values. It has pi to how many decimal places? 6, 3.142, you know. And we can do things like calculate the circumference of the Earth at the equator. There we go. And we can use it to do mathematical things like converting angles to radians, etc., and get the value out. But this is just really, so we've got 3 angles there, 30, 60, 90. We got the sine of them. We multiplied them by pi and divided by 180, and got the sine of the values within the bracket. So here we've got a function. We've got, you know, the code I've highlighted will generate 3 numbers. Okay, there we go. And then what the brackets do is apply the sine function to them to generate the radian values of those angles in degrees. So here we're not really talking about sines and cosines. I just want to show you that there are a number of inbuilt functions and also and that you can use R as a kind of calculator. But I've got a calculator on my phone, so why would I need to do that? Much more interestingly is the use of different data structures in R that enable us to do things. Okay, so here are a number of vectors. Well, vectors are kind of little, I suppose, strings or linked. Sorry, not linked. They're a sequence. They're not a sequence. Implies some ordering. A kind of a list of numbers might be the easiest way a list of values might be the easiest way of describing them. And they can be numbers, such as this one, and this just returns the values that are concatenated by C. So C, if you notice above, we kind of slip that in up there. C. Okay, if you want to have a group of numbers or values, each of which are separated by a comma, okay, they need to be in brackets and they need to have a C around them. And what C does is concatenate or combine the values. So we can print out vectors defined in a kind of a little list. We can get the numbers between 3 to 10. Okay, this should not be so, and we could adjust that to be 100. There we go, we got lots more numbers. I'm going to undo that. See, we can also have vectors of true and false values. And so vectors can be numeric, they can be logical, true and false. They can also be text. Okay, and we can assign vectors to variables. And here we're going to overwrite x and print it out. Let's have a look at x. Great, and we're going to overwrite y with a new variable. So y has now changed up here, and print that out as well. So we can do things with those. We can say, oh, actually, I want to create a vector, a third vector called z that has both x and y in it. Okay, when we look at z, what it should show us is these values concatenated, combined with these values. Now, a key thing about vectors is that they have positions. Okay, so the first thing I will do is I'm actually going to add in another little example here, which isn't in the practical. So the first thing is we can return. So if we look at what x is, let's just have a look at x. Oh yeah, it's got 6 values, 2, 3, 5, 2, 7, 1. Now if I want to return the third value, I'm now using a different kind of bracket. I'm now using a square bracket. And if I type in x square brackets 3, it will return the third element of x, which I know, which I'm expecting to be 5. Okay, so if I just run that, yes, number 5. I can also kind of say, well, okay, don't just give me the third value, give me the third and fourth value now, or the third, fourth and fifth value. Now remember, if I type 3 colon 5, I'll get 3, 4, 5. Okay, if I do 3 colon 500, I'll get 3 to 500. So just going back to the example here, if I type in x 3 to 5, okay, I'll get the third, fourth and fifth value of x. Let's have a look at x again to remind ourselves. And so let's have a look at those. There we go. The third, fourth and fifth values of x are returned. Now, if this works, if we want to get sequential values out of x, but if we want to say get the second and fourth, then we again need to use a little vector to subset our vector x. So C2 to 4 just gives 2 and 4. So if we pass these in, we'll get elements 2 into the square brackets. We'll extract elements 2 and 4. Okay. So I'm now at the kind of bottom of page 4 on the practical and at the top of page 5. Now we can also use negative numbers to omit specific vectors. Let's have a look at this on their own. Let's have a look at minus C2 and this little vector here. Oh, sorry, it didn't copy out. Hold, bear with me. Okay, so if we type in, let's just do this from first principles, C2 and 3, there we go, 2 and 3. What do we think this is going to be? -2 and -3. Now, when we're working with, positional elements, so we're trying to extract elements in the square brackets, we can also use that, so just remind ourselves of x, we can also use the negative values to rather than extract elements, is to remove them. So here we've got -2 and 3, so I'm expecting these two values to be excluded from this piece of code by running this piece of code. Okay, so what happened here was that 3 and 5, the second and third elements were excluded. So there are a number of ways of here's our vector x. There are a number of ways that we can extract elements from x. A final way is to use logical values. Okay, these are. Do you remember that these are? I'm just going to get rid of this message. You should too. There are a number of ways that we can. You remember that one of the things we can do is create vectors of logical values. Well, we can use these to also extract data, extract elements from a vector. Okay, so if we just run this, if we just, in fact, I'm going to run this one first. Is x greater than 4? Now let's just remind ourselves of x. So I'm expecting the third and the fifth element to be true and the others to be false. Let's have a little look. 1, 2, 3, the third element, 4, fifth. The fifth element is true. So we can use that logical vector to extract elements from x. So we can say, show me, what this is saying is return the values of x that are greater than 4. So show me x, but remove the values that are greater than 4. Okay? So here it's just pulled them out. Okay, so that's vectors. Vectors are kind of, if you like a kind of line of a list of numbers. They don't have any dimensions. They have a length. So I can actually type in length x, and it should tell me how many elements are in x. Sorry, that's length 6. I knew it's 6. Okay, that was a typo by me. But often we have, if you think about spatial data, it's often in like we're going to use it, or data, it's often in some kind of tabular format. It has rows and columns. Now in R and in many other programming languages, these are wrapped up into either matrices or data frames. And don't worry, we're not going to go into like matrix algebra or anything like that. A matrix is a kind of rectangular array of data elements. Okay, a data table is a similar kind of thing. Now we can make matrices in lots of ways. So first off, just recall that what this will do is return the numbers 1 to 10, and we can make a matrix of that by specifying that we want to have 2 columns, and it will create. Oh, there we go. It's gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's kind of done it by column, hasn't it? It's gone down the first column and then down the second column. We can change the ordering. We can say, well, actually, we want to create a matrix, and this time we want to do it by rows. So now it goes 1, 2, 3, 4 across each row, etc. Okay. And we can also, make matrices, you can also make matrices with letters. So here's the letters 1 to 10, a number of columns, and in this case, it's by row is false. Now, key thing about matrices, okay? Matrices, and this is a difference between a data frame and a matrix, is that a matrix can only hold values of one data type. Okay, so these are what we've been playing with here are all numeric, or they're all letters. You cannot mix elements together. If I tried matrix, let's just try this, see what happens if you do. I'm just going to do something daft. Okay, I'm going to add in 1 to 2 to this. What it will do is it will so remember 1 to 2 will give me the values 1 and 2. In fact, I'll do 1 to 4. I'll do, there we go, 1 2 3 4. Now what this will do is create a matrix, I hope, but now look, the 1 2 and 3 and 4 have been turned into characters. They've been turned into text rather than being numbers. So the key point here is that matrices can only hold data values of one type. I'm just going to undo that code because I will forget. Now, data frames are different. Data frames can hold lots and lots of different kinds of data values. Now, we're going to load some data. R comes with lots of data sets, and the US arrests data is one of them. So if you just run data US arrests, you will see that you've got a data frame pops up into your environment. So let's just run that. Okay. Oh, it's a promise. Well, let's have a little look at what that is. We've now got a variable called US arrests. How can we have a look at it? Oh, it says it's a data frame. Okay. Notice that changed, and we can now see it's 50 observations, that's 50 rows or records, and it has 4 variables. And we can examine the data frame by using the head function, and what this does is print out the first 6 rows. Its unknown but just as useful sister is, and notice how RStudio tries to populate the what I'm doing, so I'm going to take advantage of that. I'm going to have its ugly sister, if you like, or its unknown sister is tail, which shows us the last 6 rows. Okay. And now this has dimensions. Okay, so now if you remember a vector, if we have a vector called x, if we did dim x, what are the dimensions of x? It doesn't have any because it just has length. Whereas it does have a length. Okay, but data tables, data frames and matrices have dimensions. So we should see, here we go, it's telling us that there is 50 rows or records and 4 columns or variables. Now, interestingly here, if you notice, we actually have 4 variables are, different types of crime with a little bit of population for each state in the US. We don't actually have a variable called indicating the states. This is actually in what's called the row names of the data frame. So let's have a quick, don't know what I did there. Let's get back to big. Oh, incidentally, while we're here, if you feel this is all a bit cramped, you can make your screens bigger. And I think I might make mine a little bit smaller to get more in. Okay. So where were we? We were looking at the dimensions of US arrests. Yeah, no, so one of the things is that it hasn't got a variable describing, indicating the states themselves. These are in the row names. So if we had a look at the row names of US, now I'm hoping you'll populate me here. Yeah, thank you, save my typing. We should see that it's the 50 odd mainland states. Okay, it'd be useful to have these as a variable. So we can matrices with data frames. This is not possible with matrices, but data frames have names, and we can access. So if let's have a little look here. We've got these variables called. Well, let's do it a different way. Let's have a little look here. I'm going to type in, what do I do there? Row names, US arrests, we did that. And I'm going to put a comment in. Shows the row names of the data frame. See how bad a typer I am. Okay, but it also has column names. And guess how those are accessed? Column names, USA. Oh, deaths. No, let's not go there. Okay, and what I'm hoping to see, remember I'm hoping to see murder, assault, urban pop and rape as the column names. Great. Now, I can access these. I can access each of these by using the $sign. So the name of my variable is US arrests. And if I I put a $sign, RStudio automatically tries to suggest which variables I might be interested in. Let's go for murder. Okay, and if I print that out, I should get 50 values of the murders for each state. But I'm getting no indication. This is just another, this is, very similar to, it's just a list of numbers in a similar way to the first Y that we created here. Okay, so we've got in our data frame, we've got a variable called murder, and we can access it with the $sign. Okay, great. So let's put a little comment in that. Variables in a data frame can be accessed using the $sign. Okay. Right. We can also. And just so you're reassured, we're just really at the top of page 6 in the practical. We can also create a variable. Okay, if we could create a variable called state, and we can do that just by simply writing it. And now, if I ran that now, I'll just run that. It'll say not found. Don't know what you're talking about. Null, nothing. Okay. But if and you recall that this returns the row name, but what I can do is assign, I missed off the bracket. I can assign these values to this variable, okay, in the data frame US arrests. Okay, let's do that. And now I've got this value, so let's have a little look at that in there. So I've now got 5 variables. I've now got this, the states as row names. I don't really need that, but because I've explicitly listed them here as a variable. And so now I can set the row names to be, I know there's 50 variables in here because I did dim arrests. Perhaps, and I could, if I do 1 to 50, that'll generate, and I can assign that to the row names. Okay, so now if we have a look, this will be a nice little. So here we can see 1, 2, 3, 4, 5, 6 down the side, and we've got a variable, all very lovely. We can use the str function to have a look at the formats of the data attributes. So we've got something here, we can see this, and we can click on this, and we can have a look at the data as a data table. If you click on a variable that has, more than one dimension, and we can also get that printed out to our screen, and the data frame. Here's our $signs with the different variables, and we can see that murder is numeric. Okay, it's got values that aren't integers. Assault is integers. That's the count, so they're counts. So that must be a murder rate. Okay, the urban population is some factor. Okay, it's probably, if we can have a look at this in a minute. We know the rape is some rate as well, and we have a character variable with the names of the states. Okay, now this is an internal data set, and so I've not looked at this, but in theory there should be a help file for this. Let's see what happens. Yes, there is. Violent crime. So now we can see what the data are recording. Arrests per 1,000, assaults, numeric assault arrests per 1,000, what, per 1,000 people, per 1,000 arrests. I suppose it must be arrests, per 100,000, sorry. Numeric opens, percent, okay, so that makes, those data sets make sense. What's interesting is the assaults are integers. Anyway, that's what was, we can actually also show that by using a very fancy function, a very useful function, but it can be one that's difficult to get your head round, is the family of apply functions. There's lapply, sapply, there's apply itself. And what sapply does is say, right, I'm assuming you're going to give me a data frame and that you want to do something, a function, to each of the columns, each of the variables in the data frame. So what this will do is apply, you remember how we did the class function here? To say, well, what is class US arrests? Okay, we could say class US arrests $, let's have a look at state. We've just created it. Character, and that's great because that matches with what we found here. Now, if we wanted to, rather than doing that for each variable, if we wanted to apply the same function, okay, to each element, to each column in a data table, we can use the sapply. So let's see what this returns. Okay, great. So what it's turned around and said is, it's done that, and it said, well, murder is numeric, assault is an integer, urban population is an integer, rape is numeric, and state is a character, just as we got from the str. Now, especially for data tables, data frames and matrices, the summary function is really useful. This gives us a little indication of the distribution of numeric values in our data sets. Okay, so here we can see what it returns is the minimum, maximum, the mean and median, and then the 25th and 75th percentile of the distribution. So they're like, you know, the median is the 50th percentile. It's the one that's in the middle of the distribution. These are the two that are out at the quarters around the median, and often you will hear the interquartile range referred to, and that's the spread between the first quartile and the third quartile. But these values give you a very interesting summary of the data. So we can see, for example, that actually the range here is quite narrow. This murder varies between 4 and 11, really between the quartiles. We're not too bothered about the minimum and maximum; they could be out at extremes. And here, but assault is much more common. So the values are larger, but also the range is massive, isn't it? You know, this is kind of, I suppose 109 to 249, that's 2.5 times. I suppose that's the same as between 4 and 11. But the rape is much narrower. Here it seems to be hovering around 20% as a kind of median value, with, you know, sort of, or 20 rapes per 100,000 arrests. And you know, for whatever reason, these values much narrower. It's range between 15 and 26 in the interquartile range. Okay. Now, if we wanted to look at the standard deviations of these, let's just do this now. Okay, we could do two things that we've just done. We've just done the sapply, and the function for standard deviation is SD. Standard deviation, great. So we could do that. So instead of doing class, we could do SD. Now, one problem is here that we've got a variable that isn't a numeric, okay, and so standard deviation won't work. So if we apply this, we'll get some sensible answers, some sensible responses, and some sensible and some stupid ones. So let's have a little go. Yeah, look, it gave us a warning saying, look, okay, I can give you the standard deviation of the values that are numeric, but the state one I can't, and it's giving me a warning message. Now, I don't mind warning messages because it's just saying, watch out, what are you doing? Are you doing something daft? Okay, it's error messages are when things don't work, but warning messages are just things, oh, let me just have a think about that and check. Okay, now we could, I'm going to jump. I'm going to just move into the next section a little bit. What we could do is run this slightly differently and say, well, actually, I don't want to look at all of the columns. I don't want to look at the fifth one. And you remember, a minus removes something. And here we've got our square brackets again. Okay, but now they've got two elements. Square brackets work with rows and columns. Okay, so here you specify these. I've just put those words in. That won't work. That's net. But if we compare this to what we did with, let's say, x 3 to 5. Okay, so here, where are we? Rows and columns. So if we compare this with our x 3 to 5, what we're saying here is x is going for, these are positions. Okay, we're essentially, that's what we're doing with 3 and 5, is we're saying give me those positions 3, 4 and 5. Alright, and what we're doing with, when we go to here, let's go back to what we were trying to do. So we were going to say, well, I didn't want column 5, minus 5. So here we've got this kind of notation between rows and columns. So if we run this now, we shouldn't get that warning message. And that, just so you know, that's me just being lazy. But what I could have done was do 1 to 4. Or I could have done, you know, if I was being really technical, I could have, they will all give me the same answer. C, 1, 2, 3, 4. Close brackets. Okay, they will all do the same thing. Now we're starting you know, so I'm going to put a little note in here. The format of selecting elements in matrices on data frames. Okay. Okay, we're going to come back to this now. I suppose the final thing I would just do is that we can do, I'm just checking where we are in the practical on my other screen. Come back to me. And so the final thing, we've done a summary, that's where we are, go away. We've done a summary, so here, this is what we should have done at the bottom of page 6. And then we know that these are numeric, and we've done a little bit of extra s-apply in there, and you know, and so on. But now we can, in fact I might just keep all of those things I was doing. I'm going to put a little note in here, mucking around with s-apply and selecting variables in matrices and DFs. Okay, so you should be noting these things. So this is single dimension. Okay, and the format here. Okay, so there we go. Mucking, really can't spell, can I? Okay, so the final thing I wanted to do in this section here, just we're now at the top of page 7, is just to plot these. This is a very simple plot, and these are very useful. And what I'm hoping is that the plot will appear in this window. So if I enter that now, and that's great. And these show me, these are scatter plots of pairs of each pair of variables in the data frame. So we've got 4 numeric ones, and what I've done, look here, just give me 1 to 4. You can unpick this, but this is saying plot character is a dot. It's sex, yeah, it's not as you know it. It's character expansion, so I'm making them about half the size of the default. I'm giving them a grey. This is, I mean, I could just kind of do this. It doesn't have to have all this fancy stuff. I could just do this. Plots, US arrests for... Oh, notice how our studio then doesn't like it because I haven't closed the bracket. Oh, yeah, it's telling me there's something wrong. Okay, right, so we'll just do it that way. And we can just see that I just get the plot. The plot character is a little bit bigger. And that's the default plot. But actually what I want to do is I can add in the upper dot panel to get the kind of local trends. And we can see here the kind of relationship, the trends between the data. This is not fitting a regression line, it's not straight lines. They're kind of almost like a moving window kind of line. So here between murder and assault, we've got almost a very straight linear relationship. Urban population, well, yeah, it's a little bit, but here this is interesting. So low levels of areas of low levels of rape and murder are related, but as rape gets greater, it loses its relationship with murder. So there's something going on, and assault's the same. Okay. But look at that, that's a kind of almost kind of linear relationship with population. So there are different kind of distribution and relationships between numerical relationships, not causal relationships between the variables. Okay, so matrices and data frames. I hope you can see how these are really useful and relate to what we've been doing with data in Excel and things like that. There are lots of other data types in R, but I think as the moment these are the ones you need. Okay. So I suppose we've covered R as a calculator. We've covered R as some of the two fundamental data types that we'll be working with in this module: vectors and matrices and data frames. And I suppose the third thing is just to think about R as a little bit more than just a calculator. R is a interactive programming language, and so what we can do here is we can so here look, we can kind of create variables. So we've done some of these already. We can create a vector called kmvec, which is a vector of 0 to 100. Okay, there it is, 101 variables. And we can convert, let's imagine those are kilometres. We can do things like convert kilometres to miles. Okay, and we can then create a data frame by saying we want our km to be k. So we now have two variables called miles and km underscore vec, and we can create a data frame with those. Okay, by using the data.frame function and saying we want a variable called km to be km underscore vec, and we want a variable called miles. And remember that R is case sensitive, so capital M miles is not the same as lowercase m miles. So if I was to type in, we've got a variable here called miles. If I was to type in miles and say, come on R, give me miles, they'll go, oh no, it's not found. Whereas if I did miles, they'll go, oh yeah, here you go mate, no worries at all. Now we can combine these into a data frame, and we've called this df. Could be anything. You could call it bananas, Bernard, the usual. We could call it xy. We could call it kmm, anything. In this case it's called df, and we can see that pops up. Again, if you click on it, you can see it there, and I don't usually do this, but I hate doing this, but there you go, you can kind of look at it there. Ooh, a spreadsheet view. But I much prefer to do it in the console. Let's have a look at this. Ah yeah, I can see what's going on there, brilliant. Okay, I'll get rid of these. So we've got this data, so we can kind of do things like create data frames as we go. We can do for loops, and these kind of do things repeatedly, and this is going to sort of say, well, print out I will take the value 1 to 10. And we know that's 1, 2, 3, 4, 5, 6. So for each value of I, 1, 2, 3, etc., print out I, and print out and do paste printing I. Okay, so paste is just copy. It just is a function that pushes things together. Okay, so if I did paste printing 3, let's just run that. It'll just put printing 3. You see what I'm saying? But it's going to be I. Yeah. So we can just run this loop, and it'll just run round and print out 10 printing statements. Okay, each one is on a separate line. Now we could then go we can do another one which converts kilometres to miles. In this case we've got a sequence of, and seq is a really nice function. You should have a look at the help for that. It's really useful. Okay, so you can generate a sequence of numbers, and its syntax is sequence from, to, and by. Okay, so this is going to go from 10 to 100 in steps of 10. Okay, so let's have a little look at that independently. Okay, I'm just going to wang that here, just for the men, for convenience. So sequence, great. Now, this could be, you could do anything here. You could do 7.5s, you know what I mean? You get a different sequence. You could do sequence 1 to, I don't know, you can change this to anything. Okay, so you can get different sequences out. Sequence seq is a very useful function. So for sequence 10 to 100 in steps of 10, print out km. So that's going to be the value 10, and then the result of multiplying that by 0.621, a conversion to miles. Okay, so this should just do that. There we go. So we've got on the left hand side, we've got our values of our variable called km, and then the result of multiplying that by 6.21. Okay. So just to see how functions work, we can do lots of things here. Notice now we've introduced these third set of brackets, which is very common for code snippets. So we've now had 3 kinds of brackets. We've had the round ones for functions, the square ones to identify elements, positions in either vectors or in data frames, and now we've got these curly ones which group chunks of code. That's probably all you need to know for the moment. And what this does then is this, for J in 33, 55 and 66, it kind of adds, we've created a variable called answer, and answer is 0, and then as it runs through this loop, it adds in turn 33, 55 and then 66 to answer. Answer gets J, which will be 33, 55 and 66, plus the answer. So answer is updated in this loop each time. Okay, so now if we do that and then have a look at the results, okay, so what it's done, it's gone through the loop, it's added, I'm just going to, my dog is stood on a chair behind me. Get off! Bloody idiot. Sorry about that. That's really thrown me. Honestly, that was not a nice chair. She was stood on like an office chair, not a comfy chair. Bloody idiot. Anyway, just to go through that again. So we can redefine answer as 0, okay? And then we can run this loop so that each time R goes round this loop, okay? In the first iteration, J is 33, then it's 55, then it's 66. And each time it goes around the loop, it updates answer with the current answer plus the current value of J. Okay? So again, we can see that is combining those. Now, obviously what this has done is just to add the numbers together, and actually it's a little bit easier just to go, well, give me the sum of those values. Okay? Alright, so we're now, where are we in the practical? We're kind of just scrolled down. We're now at the top of page 9. Okay, we've got we're gonna go through some data selection options. I don't know why. Just reinforcing some of the things we did with the USRS and here when we pulled out these numbers, and we're just going to go through that in a little bit more detail. Okay. These are basic data selection operations. We've already described how to get things out of vectors, but we will mostly be working with data that has some rows and some columns. So understanding how to kind of work with data frames and extracting particular rows and particular columns, so rows are observations, columns are variables, is really important. Okay. We can plot these as we did before, okay, and this time I've made the character expansion 1.5, so they're a little bit bigger, and we know about their names because we've created them, and we know that we can extract single elements from these, okay, so names, US arrests, rape and murder, and we can extract, so the first and fourth of those. So here what we've done is say, give me the first and the fourth. The next line gives us the fourth and the first. So we can say to R, look, names is just a vector here, and we're just pulling out the first and the fourth and the fourth and the first, or in any order we want. So we can essentially say to R, right, okay, I want to plot, rather than it being murder, assault, rape, urban population and rape, I want urban population, rape, assault and then murder. Let's see if that works. Urban population, rape, assault, and then murder. Yeah, so we can change the way that R does things by passing we can pass our data, in this case to a plot function, ordered with the columns ordered in a particular way. And the key thing that I'm trying to get for you is to kind of really understand this row and column locations in square brackets. Okay, this is really important. Okay, and what we have is, I will go back to this, and actually I think you maybe ought to include something like this. That we've got something here where what we're trying to do is to kind of, I think this will be a useful comment to myself, okay, never mind to you. So here we've got these kind of square brackets in rows and columns, okay. So the first row is, US arrests, open square brackets 1, comma. So let's have a look at that. What are we expecting to get? We're going to get the first row. We know there are 5 columns. I'm expecting to get 5 values out of this. Okay. Yeah, great. I think I've got the row name as well. 1, 2, 3, 4, 5. Yeah, as expected. I can also just pull out the third column. I'm expecting, what am I expecting here? I'm expecting third column is urban pop, and I know that that's an integer, and I'm expecting 50 integers to come out of this. Hey, there we go. All right. Now, what am I looking at here? I want to have a look at the 3rd, 4th, 5th and 6th column, as well as the 10th and 11th, and I want all the rows. So I'm not saying, look here, I'm having all the rows. I'm not saying anything about, all the columns. I'm not saying anything about the columns, but I am saying something about the rows. I want the 3rd, 4th, 5th, 6th, 7th, 10th and 11th. Let's have a look. Okay, 3rd, 4th, 5th, 6th, 10th and 11th. Great. Now, what I can do is I can do that using an index. I might not pass in this every time. I can actually say, well, I want the 1st, 2nd and 3rd, and if I can do that, I can overwrite x. X is now 1, 2, 3. If I do names arrests, it will give me, murder, assault and urban pop, and I can then use that to say, well, what these data here, look at the gap there. I'm passing x in, so I'm going to get the 1st, 2nd and 3rd columns, and I'm going to plot those. So I'm going to overwrite this here, this plot, and it will just have what urban, oh no, because this was reordered, wasn't it? It'll have murder, assault and urban population. Okay, murder, assault and urban population. So it's really important that we understand that we can select rows and columns out of tabular data. Okay, let's just scroll down. Again, there's some more of this. Numerically, the code, we can get the first 10 rows of columns 1 and 3. Great. We can actually specify those using, look how this is doing the same thing. These 3 lines of code are all doing the same thing. Okay, they're getting the first 10 rows and the 1st and 3rd columns. And the first way is by specifying 1 and 3 in a vector. Okay, combines. Remember, the C combines values. The second way is saying, well, I'm going to pass you a vector of named variables. There we go, murder and urban pop. And these, what I'm going to do now is in the US arrest table, I want the first 10 rows, and I want these named variables. Okay, so if I do that, I should get the same thing. Now, if I don't spell this correctly, or I put, I might get an error. Okay, in fact, let's not go. That's a deeper point. And the third way of extracting them out is to say, well, I could have true and false statements. So the first is true, second is false, third is true, false and false. So that is going to give me 1 and 3. Okay. And we can also do things, so, well, actually, I'm only interested in the states where the murder rate is greater than 10 and the urban population is less than 60. Find me those. Okay, so this is this will evaluate each of these 50 elements and each of these 50 elements. Let's have a look at them. There's the urban population, there's the murder rate, okay, and I'm going to find the murder rates that are greater than 10, which are, oh right, a whole load of true and false statements, and the same for the same locations where the arrest rates are greater than 60. So I want to combine these two true or false statements. Let's have a look. Okay, and these are the locations for which both of those, this is a vector of locations in US arrests for where both of those statements are true. Okay, murder is greater than 10 and urban pop is less than 60. And we can assign that to a vector, n, which has just popped up here. Oh, it's a logical vector, so that's a new one. We've got an integer, we've got numeric, I think we've got character. We had character before, didn't we? But we've now got a logical vector. So if we have a look at n, it will be these true false statements, and we can use that to say which rows here, which rows are you going to print out. Okay? So here what we've done is we've done a little bit of investigation of the data table. We've said, well, find me the states for which these conditions are true. Okay? And what you should do, these kind of operations are really, really useful, you know, especially when we're doing kind of analysis of geographical data. Okay, so you can see there are a number of operators. If you look at comparisons, you can see how these things work. Okay, these are very straightforward. We've got less than, greater than, but also, you know, here we have less than or equal to y. Okay, so, you know, if we had, I don't know if that would make any difference to our selection, but let's just try that. Doesn't look, oh yeah, we've got one more. Now we've got Georgia in because it has an urban population less than or equal to 60. So your choice of these does make a difference. Okay, the next part of the practical is going to look at the survey data, and we're going to go through some of the things that you did. In fact, I might just pause this here and I will come back to it so that you've got a smaller snippet.